question 1. So just a couple of CVAT equations here. For part A, we know that V is 0 at the peak of the projection upwards, so at the maximum point the speed is 0 for a second before it starts coming down again. We know the acceleration is against gravity, so it's minus g. As we throw a ball in the air, it is slowing down because it is fighting against gravity. So A is minus g, so minus 9.8, and we're told that the maximum height is 40 meters, so S equals 40. So using v squared equals u squared plus 2as, I've rearranged this to make u squared the subject, and substituting in these three values we get u squared being 784, so u being the square root of 784, which is 28 as required. Now for part B, note it says times plural, so that immediately should suggest you're going to be using the formula that leads to a quadratic, so we're getting two solutions. Anyway, u is 28 as we know from part A. The acceleration is still fighting against gravity, that's minus 9.8, and we're looking to when it goes past 33.6 meters, well, it goes to a total height of 40, so it passes 33.6 meters on the way up and then again on the way down, so hence the two values. So substituting into S equals ut plus half at squared, we end up, once we've rearranged it, with this quadratic formula to solve. It doesn't factorize. Now this is a tad confusing because this a is not the acceleration. I'm just trying to use the coefficient of t squared being a, the coefficient of t being minus 28, and the coefficient of c, the coefficient at the end being c. So a, b, and c. I've just done this to tie in with the formula format that you'll be familiar with from GCSE of minus b plus or minus the square root of b squared minus 4ac all over 2a. Anyway, substituting these three values in, we get this, which simplifies to this, giving us the two values for t of 1.71 seconds or 4 seconds.